Calculate the standard deviation for the following set of sample data: 5, 13, 3, 10, 8. First, calculate the sample mean. Well, because we only have a few data items, I think it makes sense to just simply calculate that mean just by adding together our data items and dividing by the number of data items, which in this case is 5. So 39 divided by 5 gives me a mean of 7.8. Next, fill in the data table below with the deviation of each item and the square of each deviation. So the deviation of each data item, that is the distance of the item from the mean. And we're trying to get the average distance of each data item from the mean to get an idea of how spread the data is out about the mean. So that's what we're working on. So let's start with getting the deviation of each item. So with 5, to measure its distance, I take the value 5 and subtract the mean, which is 7.8. So 5 minus 7.8 is negative 2.8. And then if I take 13 minus 7.8, that's 5.2. Now, notice that 5 had a deviation that was negative, and 13 has a deviation that's positive. And all that means is 5 is a number that is less than the mean, and 13 is a value that's bigger than the mean. So no problem there. 3 minus 7.8 is negative 4.8. 10 minus 7.8 is 2.2. And 8 minus 7.8 is 0.2. So next, in order to find the average of these deviations, what we would do is add each of the values together. So, of course, I need to take into account positives and negatives. And once we add these numbers together, we will then divide by the number of values, and that would give me the average deviation. The problem is that it's not just this data set, it's actually just a property of how the mean and deviations work together. The sum of your deviations is always 0. And so that's an issue because what we ultimately run into is every single standard deviation that we try and calculate would just be 0, and that's not a very useful measure. So there's a couple of ways around this. One way around it is to take the absolute value of each of these. We could just make them all positive. And that would lead to a measure that's called the mean absolute deviation. And that is a measure that's used in statistics sometimes. But a more common measure is called the standard deviation. And instead of taking the absolute value, what we do is we square all the numbers. So if I took 2.8, well, actually, if it's negative 2.8, but when you square a negative or a positive, it doesn't matter. The result is positive. And that's what we're trying to achieve here, is we're trying to make sure the answers that we come up with are all positive. So 5.2 squared is 27.04. Negative 4.8 squared, and I'm not bothering with the negative here because I know it'll end up being positive. And 23.04. And then if I take 2.2 and square it, that's 4.84. And 0.2 squared is 0.04. Now I'm going to try and average these numbers. Okay, so the next thing that I would need to do is add them all together, because when we do an average, we add numbers together. Oops, hit enter a little too early. All right, so I'll just say that plus the sum that I had already. So 62.8. Okay, so in the next part it says calculate the sample variance, okay, using s equals, well, in fact, that should be an s square, right? That's the symbol for variance. So s squared equals the sum of the deviations squared, which is what we have here. So this sigma right here means the sum of a bunch of data items. These are those data items, so that's what we got. So we'll take that sum, 62.8. Then if we're doing a sample variance, we actually divide by 1 less than the sample size, right? And there's reasons for that beyond we can really explain at this point in the class, but just know that's how we do it. In the population standard deviation, you use n. The sample standard deviation, you use n-1 in this denominator. So you always need to make sure you know which one you need in an example to make sure you get the right value. So 62.8 divided by 4 in this case. So that's 1 less than 5. So dividing that by 4, I get 15.7. So that's called my variance. Now, the problem with the variance is it's trying to estimate the average of all of these numbers. But if you'll notice, it's much bigger than any of the individual numbers. And the problem is the act of squaring. So to counteract that, what we do is define a new measure, which is called the standard deviation, which is the square root of this variance that we just came up with. So the standard deviation then is the square root of 15.7. Which is 3.96. And I'm just taking to 2 decimal places by choice. Of course, follow any rounding instructions in the problem.